Ignition really helps companies solve their data problems by making data easily accessible to anyone. This democratization of data really helps companies digitally transform their processes to be more efficient. If you look at this graphic that we put together, we're really looking at the whole picture. And taking a look at the whole picture, it's important to understand the parts that go into the whole and what your organization really needs to transform each item here from a traditional model to a modern set of technologies and capabilities is going to be potentially similar and potentially different for each one of these steps. So just reviewing this at a high level, the first is collection. Collection is where data is collected from devices or other sources on the platform or the field. Data modeling is where data is structured in a unified way and is made easy to understand. Publication and subscription, well, really data needs to be accessible in an open, secure format supported by industry standards and strong security. For industrial and business applications, that fourth item right there, after data is accessible, an organization needs to be able to see and explore data. Data is turned into insights and action through the creation and connection of industrial and business applications. The last item there, analytics and machine learning, really no system today is complete without insights that are honestly very valuable that can be garnered through analytics and machine learning tools. So let's explore how Ignition addresses each one of these areas. If we start with data collection, this is a challenge for many companies today. To solve this challenge, Ignition leverages open standards and modern technology to act as a hub for everything on the plant floor. It can connect to virtually any kind of PLC through native drivers or through OPC. It supports all major databases, historians, other ERP and MES systems, any third-party web service, RESTful communication, SOAP-based web services, integration with cloud services like Azure and AWS, and the ability to get data to anyone on any device. By leveraging MQTT, Ignition provides a streamlined data pipeline for IIoT, which we'll talk a little bit more about in a second. And as you can see, really, Ignition bridges that gap between the OT and the IT data on that data collection and connection side and enables that total system integration. Of course, after collecting the data, it's important to go to the next step. It needs to be modeled. A few devices and edge systems support proper data modeling, but most do not. Whether they do or whether they don't, Ignition either enables using existing models or it allows folks to define your own models. Once again, I'm going to bring Arlen back. Arlen's an expert on data modeling and the spark plug specification. So I'm going to give you the mic for this part too, Arlen.
Thanks, Kevin. Appreciate it. So when Sparkplug, it basically provides a standard for modeling OT data. So it's a specification that defines how to use MQTT in a mission-critical real-time environment. It's important to understand Sparkplug does not change the underlying MQTT transport in any way. One of my favorite sayings is that, the great thing about MQTT is you can publish anything you want on any topic. The problem with MQTT is you can publish anything you want on any topic. So really at a high level, what does Sparkplug do? Well, the first thing it does is it defines an OT-centric topic namespace. Now, what this results in is plug and play auto discovery. If you know just a little bit about pub subsystems is that you've got to be able to go in and basically do a wildcard subscription on a given topic so you can discover things automatically. By having the notion in Sparkplug of a group, a node, and the device ID, we immediately know that a new device or a new sensor has been added and what it can do for us. So in other words, the sensor is telling us about itself. So plug and play. The second thing MQTT Sparkplug does is it defines an OT-centric data model and asset structure. Now, this is very important. It's kind of an epiphany that we've had over the last 4 or 5 years working with customers, because originally we were really focused on having the single source of truth for a measurement, for a process variable, for an ignition tag, right? To be able to define that tag, to give it a name, to give it a value. But what we were finding as we start migrating into other applications, especially in cloud, we need to be able to define that model all the way at the edge. So imagine with an ignition system being able to take and build a model with your tools, i.e. building a UDT. We can publish that model directly from the edge of the network. The third thing that Sparkplug does is it defines an OT-centric process variable payload. So again, I'll go back to my Modbus example where for the last 40 years or more, we've been stitching together Modbus register value pairs. We have to manually go in, give it context. With Sparkplug, at the very edge, we can use the ignition tools to give that measurement a name, a value, a timestamp, a data type, engineering units, engineering ranges, quality, and any other custom property we want to add to that measurement to give it context for everybody else in the enterprise to consume that. Again, give it context so that not only the engineer that programmed the PLC knows what the heck that value is. And then the last thing that Sparkplug does is that, as we've defined or described before, is that MQTT lets us do report by exception. In many cases, that you're looking at reducing the overall bandwidth required for the same number of process variable updates, 80 to 95% less bandwidth to do that over your network. But to do that, you have to have proper state management. So Sparkplug defines that death certificate, if you will, of MQTT, and then that lets you do some pretty cool things, including store and forward. It's interesting that 5 years ago when we started working with inductive automation, there was this notion of, hey, if my network goes down, I'm going to have holes in my time series database. And now probably 95% of our customers use the store and forward capabilities of Sparkplug so that even if the network goes down, those process variables that would have been published are put into a queue. And when our MQTT session comes back up, those are slowly fed into the ignition historian. So basically, Sparkplug gives us that single source of truth. Now, when we look at using ignition for digital transformation, it simplifies access to data. And it's important to have this architecture that can scale and doesn't require a one-to-one link from devices in the field to applications. MQTT's overall pub-sub model is the ideal solution for decoupling your OT data for the enterprise. So if we look at that, using Sparkplug, Ignition can leverage the efficiency of MQTT to decouple devices from application, creating one streamlined data pipeline. MQTT has emerged as one of the leading protocols for IIoT. And ironically, although I say, MQTT, it was invented for SCADA and adopted by IT. But we're now getting MQTT back into applications that it was originally designed for in the oil and gas industry for over 20 years ago. Ignition's IoT solutions leverage MQTT to easily publish data from thousands of plant floor or field devices to a central location where both industrial and business applications can subscribe to that data. Because MQTT has that pub-sub model, you just subscribe to the data that you want. Now, if we start looking at that concept I told you before of data models, well, now we're starting to realize that initially we were taking measurements and we were pushing them into data lakes or S3 buckets. And we kind of realized that we dematerialized all of that knowledge that we had at the edge. We broke it up into all the individual measurements, and then we push it all up into a data lake where we've got to hire somebody to put it all back together again. Where, what if we could just take the models that we built in Ignition and immediately have them show up? So Azure is offering their Azure Digital Twin service. And then what we've worked with a lot here lately is with a new service from AWS called SiteWise. Now, SiteWise is a cloud service that at its roots, you have to define a model. And once you've defined a model, you instantiate that, creating an asset, and then asset has measurements that go into the time series database on the AWS Sitewise service. So what we've done is that being able to use that with MQTT Sparkplug, we've eliminated 90% of the complexity of being able to take a UDT setting in your Ignition gateway and having that model appear automatically in the Sitewise service. And then for every instance of that UDT, that creates an asset, and then all of the process variables are updated real time into the time series database. Now, that makes it accessible now to other people that want to use that data in cloud services. So I'm going to hand it back to Kevin, and he'll explain how the data that we put up there can be used in business and industrial applications. So Kevin, back over to you.
Thanks a lot, Arlen. We had a couple of questions come in that are really timely here, so I thought that maybe I'd answer at least one or two of them, or at least pass one over to you, Arlen. So one of the questions was, what do you have to simplify historical and live data acquisition over a data diode? The data diodes are unidirectional gateways, that's another name for them, and basically it's a one direction push of data from one side of a network to another without bidirectional communication. The good news here is that MQTT Sparkplug, as mentioned, is a standard that is available for any technology company to implement. And one example that I know of on a data diode side, Owl Cyber Defense, which is one of the major companies that does data diodes, has MQTT Sparkplug as one of the supported protocols. So you can just feed things in from one side, go right through the data diode, and MQTT Sparkplug comes out the other side there. There are a number of other options there as well. We have a lot of companies that are using data diodes, but that's a really easy answer and solution for that if you're using these tools that we're talking about.
Yeah, I'm very familiar with that solution, Kevin, and you're right. We work with Owl on that, and it is a really cool way. If you're looking at using data diodes, MQTT really lends itself well to that.
Yeah. Thanks, Arlen. And then the other question I wanted to quickly answer here, and we're going to keep a couple of these questions for the end, but this one says there's no standard tools to leverage the digital transformation and IIoT requirements, as there are multiple types of sensors and each has its own limitations when it comes to process data. Do you have any platform where we can converge multiple technologies through different protocols? This question came in about 15 minutes ago, so I think that it was before we started talking about this, but I just wanted to say everything that we're talking about here is addressing that question specifically. So on the collection side, the different protocols that are spoken with different servers, with different technologies, that's all done on the collection side. And then that data modeling puts it into a standard model so that you can do exactly what you just said, get it into a standard, move it through as a standard so you don't have to worry about all the different protocols. You certainly have to deal with them on the collection side, but as soon as you have those in place and you have the collection in place, that's cookie cutter, that's a model, you can roll that out for any similar sensors in the future and then have that feed right through the same process so that you do have standardization going forward, even though, as you say, on the actual device side, there's not a lot of standardization. But when you put this in place, it gives you that standardization across the enterprise. All right, so just as important as collecting data is what companies do with it to empower their processes. This is another area where Ignition really shines. Ignition has a robust set of development tools that enable companies to create their own industrial applications, customized for their specific needs. Because of Ignition's interoperability, it's possible to create virtually any kind of business application and subscribe and publish data with the rest of the company, such as ERPs, CRMs, and other business systems. Ignition is really powerful for building industrial applications. So things like SCADA, HMI, IoT, MES, as I've been mentioning. With Ignition, you can connect all of your IoT data, rapidly develop any kind of industrial application, and instantly web launch clients to virtually any device. Ignition can run as a web application or a desktop application, it's your choice. Ignition has powerful built-in tools for creating full-fledged systems. Ignition is also modular, so you can easily add fully integrated software modules for building industrial applications such as alarming, reporting, data streaming, and more, all inside the same platform. Ignition comes with everything users need to create any kind of application for multiple different display types. So if you're looking at desktops, industrial displays, HMIs, mobile screens, Ignition supports all of that. The designer creates a rich component library and it makes that available for everyone. It has easy data binding, it has powerful tools for drawing and scripting, and it has all of that integrated in that one integrated development environment. It's easy drag and drop. You can rapidly build and customize large projects, create custom graphics and animations, and the designers are unlimited. You can have 1 or 2 or 5 or 10 engineers that are all set up and designing things at the same time. And Ignition easily supports multi-designer setups. The designers are also free, there's no charge. Because Ignition's modular platform, Ignition offers a high degree of customization. It's made up of individual core modules that are designed to work seamlessly together. You could really think of the modules like apps on your smartphone. Apps increase the feature set as you install them on your phone. Likewise, modules increase the feature set or the tool set inside Ignition. Each module gives the platform powerful features to enable creation of industrial applications. And this architecture, what you're seeing right here, the software stack, really makes Ignition extremely flexible and scalable, as individual modules can easily be updated and added to perfectly fit a company's requirements. Ignition also has an open SDK, so if you have programmers on staff and they want to do low-level programming, you can program your own modules. However, the tool set is intended to be feature-rich enough that folks don't need to do that, and it has all the tools built in for companies. It's very rare that folks create a module. Every once in a while, somebody will, or creating something to talk to a special protocol for a special device that they've created in-house or something like that. You can create your own drivers, you can create your own sets of logic inside there. But in general, Ignition has those tools to be able to build logic even without that SDK. That said, that SDK is open, 100% available, free. If you have programmers, they'll appreciate that there are examples on GitHub. It's well documented and it doesn't require any cost to sign up or to access that. So let's take a look at a few apps that were built in Ignition. This is an app for San Bernardino County. You can see mapping tools, tank status, real-time levels, remote viewing of process variables, and centralized alarm management there. These are all mobile screens. This is a mobile app that they created. This is an app for Arian's company, which is really a quick example of OEE and production information aggregated by time, which includes downtime entries. This is one for Avery Dennison. It gives examples of managing logistics, and that's for the different lines that you see right there. And this one is used by New South Wales Rural Fire Service. This is for tank levels and load requests. This is for fighting fires, so they can see the different levels of water and retardant that are available at different airports that they can fly into. They go down to the tarmac, they load up, they take off again, and helps them be much more efficient in terms of saving the forest and saving homes and everything that they're doing there. So these are some examples of applications that you can build rapidly in Ignition. There are thousands of different examples out there, and we'll share a couple more here in a few minutes. Because Ignition's interoperable, companies can leverage the best analytics and machine learning tools as well to get an even deeper understanding of their data. Analytics are really crucial for getting real value out of digital transformation. As you probably know, being able to collect, gather, and transmit data in a structured way is great, but it doesn't have a lot of value unless there's a good way to visualize the data and garner insights. Data without context and data without analysis is just data, and you're going to end up overwhelmed with that data. You need to get information out of the data, and getting information out of the data means taking a look at the data, analyzing it. If you have a good foundation of that data, like we've just been lining out, if you have data structures and data models, it makes getting information from that data much easier and much quicker. If you need the ability to get those insights and loop them back into your decision making, you can do that now too, and a number of companies are doing that in terms of closed loop control and also providing some feedback to operators for suggestions on how to improve processes, how to improve performance, how to improve set points. One of the things that Ignition helps you do is as built-in visualization tools, and it does have built-in machine learning algorithms as well, has about a dozen of those. Its open platform nature really gives you the freedom to use not only the built-in algorithms, but best-of-breed analytics and machine learning technologies as well. It's very flexible. And many industries are really adopting machine learning as well. One industry where we've seen a lot of that in the past few years is oil and gas. We've got a couple of examples. CSE Icon is one of our systems integrators, and they solved a number of problems with oil and gas with machine learning. For example, they had operating points for wells, optimizing and predicting artificial lift. Another integrator in that space, Taiga, has many other offerings, tank leak detection, decline curve analysis, predicting pipeline corrosion, and suggesting where to explore. So the exploration inside oil and gas, basically where to consider looking for oil based on past drilling information. Oil and gas has a reputation for being slow to adopt new technologies, but really in this space, we're seeing that they're ahead of the curve, at least with integrators that we have in that side of that space using machine learning. The culmination of all of this isn't really the machine learning and analytics, but the culmination is the full set of technologies here. You end up with that business and industrial applications that have access to that data, that give you that insight, that might tie into the machine learning and analytics. It also gives you the structure so other things can tie into all of this as well. As Arlen was talking about, that pub-sub model, the publication and subscription, allow for any system to tie into these data streams, make that available, have a single source of truth across the entire enterprise. And that data modeling gives you consistent standard data models that you're working with apples to apples comparisons for everything inside the organization.